Bismillahirrahmanirrahim and Assalamu alaikum. Welcome to our YouTube channel Paper Bolt, where we are solving past paper questions of IGCSE Physics 06 to 5. Currently, we are doing the chapter of general properties of waves, sound, light waves, etc. And in that, we are doing topic 3.4 today, which is related to thin converging lenses. So let's start. But before we begin, kindly like and subscribe the channel. And if you find anything helpful in the video, kindly remember me in your prayers. So let's begin. Question number 1. Which row about converging lenses and diverging lenses is correct? Converging lenses always produce inverted image. This is not correct. The converging lens can produce inverted as well as upright images. So this is wrong. Converging lenses can be used as magnifying glass. So this is correct. And diverging lenses don't have a principal focus. No, this is not correct. So this option is also not correct. We can cut these two out. Converging lens can be used to correct short-sightedness. No, converging lens can be used to correct long-sightedness. So this is not correct. D, can produce real and virtual images. Yes, this is correct. And can be used to correct short-sightedness. Yes, this is also correct. So D is going to be our correct option. Question number 2. A student passes parallel rays of light through 4 different converging lenses. He measures the distance x and the distance y for each experiment. Which lens has the longest focal length? Okay. So basically, focal length is between the optical center and where the rays converge or pass through after, not converge actually, pass through after being reflected from the lens. So this is what we call our focal length. So the lens with the longest focal length will have a distance y which would be greater than all of the others. So if we look at the values, so it's 2, 3.1, 2.3 and 2.4. So 3.1 is the largest value. So this is going to be the lens that has the largest focal length. Okay, so B is going to be the correct option. This is just common sense. Question number 3. The diagram shows part of a ray diagram that demonstrates the formation of a virtual image Y of object X by a converging lens. One ray of light from X is shown approaching the lens. Okay, which arrow shows the direction of the ray as it leaves the lens? Okay, so obviously one has been shown, so the other is going to be, let me make it for you, this which passes through the optical lens, and then this can be, both of these can be traced back like this. Okay, so sorry, one of them is going to be here and one of them, this is always the issue with it, is going to be here. So this is how the image is going to be made. So it is going to be something like this. So out of all these, A resembles this line the most. So A is going to be our correct option. Question number 4. A thin converging lens is used to produce a real image of the object. Which statement about the real image is always correct? Okay. It is nearer to the lens than the object, not necessarily. It is on the opposite side of the lens to the object. Yes, this is correct. It is the same size, not necessarily. It is upright, not necessarily. So B is going to be a correct option, because if you see and see, it is nearer to the lens than the object. So this can't be now. If this is our lens, converging lens, so the image, the real image is on the other side of the lens. Okay? Or it's not necessary that a real image is closer to the lens than the object. Okay? Or it is of the same size of the object. No, we have seen that the object is of smaller size. The image between f and 2f ठीक है, when the object is between f and 2f, तो its image is beyond f and 2f and is enlarged. So this necessarily is not true. And it is upright, ये भी necessarily true नहीं है. It can be inverted and still be a real image. So B is the correct option. Question number 5. A thin converging lens in a camera produces a real image on a photosensitive surface as shown. At which position is the image of the top of the object formed? Okay, the top of the object, the image is going to be formed. If you see that this ray converges at C, and then this other ray is also converging at C. The C is going to be the point where the image of the top of the object is going to be formed. Okay, it's not going to be formed anywhere else. A B pe maybe the bottom of the object can be formed. So if they're specifically asking you about top, look at these two rays that have started from the top. One passes through the optical center and the other is parallel to the principal focus and passes like this. This is going to be F and they converge at this point. So this is going to be the point where the top of the object's image is formed. Okay. Question number 6. An object O is placed at a point P near to a thin converging lens. The diagram shows 3 rays from the top of O passing through the lens. Each point F is 1 focal length from the center of the lens. Each point 2F is 2 focal lengths from the center of the lens. Okay. The object O is moved to point Q in the diagram. Okay. Which type of image is produced when the object O is at point Q? Okay. Now this is the point Q and this lies between F and 2F. So its image is going to be beyond F and 2F. So the image is going to be inverted and it's going to be enlarged. You can also see it for yourself. Let me draw the lines for you. Okay, let's take this. So if you draw one line from here, let me draw it first. So now once we've drawn the line, you can see that if the object was placed at the point Q, the one of the rays which was parallel to the principal axis would go like this, and then another ray would pass through the optical center of the lens, jo ke thoda sa hil gaya, but it's okay, and they will converge at a point that is beyond 2F, and you can see that the image size is much greater than the size of the object, and then it is inverted as well. So once we know that what kind of an image is formed, it's going to be inverted and enlarged. Okay. So B is going to be our correct option for that. Okay. Let's move on to question number 7. Each point F is 1 focal length from the center of the lens. Each point 2F is 2 focal lengths from the center of the lens. Which diagram shows a converging lens being used as a magnifying glass? So when a converging lens is used as a magnifying glass, then the image is formed on the same size as side as that of the object, and it is enlarged and upright. Okay, so it usually is like this. We use this line for a converging lens. Okay, so if the object was basically the case for this situation is that the object is between F and optical center of the lens. Okay, and then one ray goes here, and if this is your F, it passes through that, and the other ray passes like this, and then they are traced backwards. Okay, these rays are traced backwards to a point. Okay, and the image is formed over here. So this is basically the case, and you've got to place your eye over here to see that. Okay, so whatever scenario matches with this one, so that is going to be a magnifying glass. Okay, the object when the lens is being used as a magnifying glass should be placed between the optical center and the focal length of the lens. So we don't see it over here. So this is not the correct option. We don't see it over here. This is the object is between f and 2f over here. The object is at 2f over here. This is the case for photocopier machine. So this is not a case for magnifying glass. This is the case for a magnifying glass when the object is placed between the focal length and the optical center of the lens, and the image is formed on the same side as that of the object, and it's a virtual and an upright image. So D is going to be our correct option. Okay, I'll encourage you to remember all the cases of the converging lens and the examples that come with it. That is going to be very convenient for you if you learn that table. So it is going to be very helpful for you guys. Okay. Okay, moving on to question number 8. The diagram shows the action of a thin converging lens on two rays of light. The rays are from the top of the object O. An inverted image I is formed. Okay. Which name is given to the distance RS? Okay, the distance RS is the distance between the optical center of the lens and the focal point of the lens. So it is called focal length, basically. So C is going to be our correct option. Do remember these definitions so that you know how to solve these questions. Okay. Question number 9. Number 9, a thin converging lens has a focal length f. An object O is placed to the left of the lens as shown. Where is the image formed and how does its size compare to the object? Now we can see that this is the focal length. So this point is the focal point, RF. Okay. So the object basically is placed between the optical center of the lens and the focal point of the lens. This case comes into play with the example of a magnifying glass. Okay, and you know that for the case of the magnifying glass, the image is formed on the same side as that of the object. It is enlarged and virtual. Okay, I'll just make the lines for you and solve it for you, and then. So this is the whole scenario. I've drawn it here. So whenever this happens, the image basically formed is enlarged and virtual because it is on the same side as that of the object. So if we look at the options, so it's not on the opposite side, on the same sides of the lens and larger than the object, because a magnifying glass enlarges the. Okay, so image is upright, larger, enlarged on the same side. Okay. Moving on to the next question. Question number 10. A person uses a magnifying glass to look at a stamp. Which ray diagram shows a thin converging lens being used to do this? Now, I've told you many times before as well, how does it happen? And if you look at these diagrams, this is going to converge at a point. The lines that come out of the object when this converging lens is being used as a magnifying glass, they never converge. They stay like this. Okay. So over here, they are going to do like converge at a point as well. And this is the wrong direction. Any line that is parallel to the principal axis after converging through the lens has to pass through the focal point of the lens, your principal focus of the lens. So यहाँ पे ये नहीं हो रहा, इसलिए these options are not correct. Only A option is correct. We've discussed this before as well. Okay, question number 11. An object is placed in front of a converging lens of focal length 15 centimeters. Which row describes the image of the object? Okay. Now an object is placed in front of a converging lens of focal length 15 centimeters. Okay. Now just look at this. This was a converging lens. Okay. 15 centimeters was the focal length. Okay. Now if the object is placed distance of the object from the lens is 40 centimeters. This means that we have to enlarge this. This is 15. 2f, double the focal length, is going to be at 30. Obviously, 15 plus 15 is 30. And then after that, it has been placed. Okay, so the object is placed beyond 2f. So the image is going to be created between f and 2f always. And so the image is going to be smaller and it is going to be inverted. Okay, and it is going to be real. So this is basically the example of the use of a converging lens in a camera, where the object, the real size of the object is reduced, the image formed is real, but it is inverted. Okay, so if this is the case, so real, upright, diminished is not correct, because it's not going to be upright, sorry, it's going to be inverted. Okay, so that is why this scenario is not correct. If the distance of the object from the lens is 30 centimeters, that is, the object is placed at 2f, so the image is also going to be formed at 2f, and it is going to be inverted, real, and it is going to be of the same size. Okay, this is the example of using a converging lens in a photocopy machine. Okay, so let's look at the attributes of the image. It's going to be virtual, inverted, and enlarged. No, it's going to be real, inverted, and of the same size. So this is also not correct. Okay, now the distance of the object from the lens is 20 centimeters. So this means that the object is between f and 2f. So if the object is between f and 2f, the image is going to be formed beyond f and 2f, and the image is going to be enlarged, inverted, and real. Okay, so this also real, inverted, and diminished. No, this is going to be enlarged. This is not going to be diminished. So this is also not correct. And when it is D, which is 10, so basically now the object is between the optical center of the lens and the focal point. So this now is an example of using a converging lens as a magnifying glass. So now the attributes of the image would be that the image is going to be virtual, enlarged, and on upright, and on the same side of the object. So virtual, upright, enlarged, these three attributes are correct according to the distance of the object from the focal length. So D is our correct option. I hope you understood the concept and the idea. Question number 12. The diagrams show rays of light from an object O passing through a thin converging lens. Principal focuses in each diagram are labeled F. Okay. So what do we have to do? Which diagrams are correct? Okay. If we look at the first one, so yes, it is correct. The ray of light that passes through the optical center of the lens passes undeviated. So this is correct. Now this one, all the rays that are parallel to the principal axis after converging through the lens have to pass through the principal focus. Okay, they have to pass through the principal focus. This is not passing through the principal focus, so this is not correct. And if we look at the third option, so it is passing through the focal point before principal focus, before it's being converged from the lens. So when this happens, after converging, the ray remains straight, just like this, and it passes through the principal focus. So the one ray that has already passed through the principal focus before it converges, it remains straight like this. So basically these two rays are opposites of one another. So 3 is also correct. So 1 and 3 are correct. So C is going to be our correct option. ठीक हो क्या? Question number 13. A thin converging lens can produce both real and virtual images. This is correct. Which row describes a real and a virtual image? Okay. Real image, rays converge to form a real image. Okay. Image, virtual image can be projected onto a screen. No. Real images can be projected on screen and virtual images cannot be projected on screen. This is the one point that distinguishes them. Okay. So B, rays converge to form the image. This is correct, but images cannot be projected onto screen. This is also correct. So I think B is going to be our correct option. Yeah. Question number 14. An object is placed in front of a thin converging lens. The diagram shows the path of the two rays from the top of the object. Okay. An image of the object is formed on a screen to the right of the lens. Okay. If the image of the object can be formed on the screen, then the image would be a real one. Okay. So how does this image compare with the object? Okay. So you can just enlarge them, these rays, and see where they converge and see what this looks like. So we can see that the image basically is inverted and a bit larger than that of the object. So it is larger and inverted. मेरे ख्याल से A is the correct option. Yes. Okay. Because we've enlarged these and we have seen that this is the object and this is the image and it is inverted and it is enlarged. So obviously is the correct answer. Question number 15. A thin converging lens is used to produce a sharp image of a candle. Various sharp images are produced on the screen by moving the lens and the screen backwards and forwards. Which statement is always correct? Okay. The image is at the principal focus of the lens. Okay, we can't actually see to that. The image is bigger than the object. The image can be smaller than the object as well. Okay, the image is closer to the lens than the object. This can be changed. This scenario can be changed as well. The image is inverted. Yes, you can see that the image is inverted. So this is the best option that you can have. So D is going to be our correct option. Question number 6. Question number 16. Which statement about thin converging lens is correct? A. All rays of light refracted by the lens pass through the principal focus. No, this is not correct because you see that the ones that pass through the optical center of the lens, they don't have to pass through the principal focus. Okay? They just go on undeviated. So this option is not correct. B. All rays initially parallel to the principal axis of the lens are refracted through the principal focus. Yes, this is correct. So all the rays that are parallel to this line, which is the principal focus, after being refracted through the lens, have to pass through the principal focus of the lens. So this is correct. So B is our correct option. Okay? Question number 17. A small object O is placed near a converging lens is shown. The lens forms an image I. Which statement is correct? Okay, now they've told us that a small object is placed near a converging lens as shown. This is the object and the lens forms an image at I. So this is the same point and same size as that of the object. So I think the image formed is going to be enlarged. Okay, number 1, and it's going to be a virtual one. Okay, so let's go through the options. The image I is diminished. Nahin, diminished nahi hoga, it's going to be larger. The image I is inverted. Nahin, inverted bhi nahi hoga, it is going to be upright. The image I is real. No, it is going to be virtual. The object O is closer to the lens than its principal focus. Yes, this is correct. If the image is formed on the same side as that of the object, then the the object would be closer than the principal focus. It would be between the optical center and the principal focus. So D is going to be our correct option. Question number 18. A thin converging lens has a focal length of 6 centimeters. An observer looks through the lens at an object which is placed 4 centimeters from the lens. Okay. Which description of the image that is observed is correct? So if we know that the focal length of the lens was 6 centimeter and the object, so it was 6 centimeters, for example, this is, and the object is placed at like 4 centimeters, at a distance of 4 centimeter from the lens. So this means that it is placed between the optical center of the lens and the principal focus of the lens. So now the image that is going to be formed will be on the same side as that of the object. It is going to be enlarged. It is going to be virtual. Okay. So and upright as well. Okay. So we will look for such option: diminished. Ones can be cancelled. Enlarged and inverted है और enlarged and virtual है, तो enlarged and virtual are the correct options. ठीक है? Question number 19. Which diagram correctly represent rays of light passing through a converging lens in the camera? Okay. Now when we discuss the case of the camera now, so it is like this is your converging lens. This is your principal focus. This is 2 times your principal focus. So the object is going to be placed beyond 2f. Okay? The object is going to be over here, and its image is going to be formed between f and 2f, and the image is going to be real, inverted, and diminished. We see now that we are so large, and when we take a picture of ourselves, the picture that is taken of us is smaller, and the image formed by the camera is always inverted, and then we can flip it. And the image formed is always real because it can be projected on the screen. So these are the attributes of the image that are formed by the camera. So if we look at the diagrams over here, so we have an object over here which seems to be bigger, and after converging through the lens, it becomes smaller. So this seems to be the correct option, but let's look at the other ones. And the image formed is inverted as well, diminished as well, and obviously it's being formed on the screen, so it's real. If we look at this one, so the object and the image formed are of the same size, so this can never happen in a camera. Okay, so that is why this is not correct. In option C, we can see that the object is of this size, the image is much bigger than that of the object. It is inverted, it is real, but the image size is much greater than that of the object. So this does not happen. Okay. And when we look at this option, though, the problem with this option is that the image is upright. It has to be inverted. So this is also not correct, and A is going to be our correct option due to all these reasons. Moving on to question number 20. An object is placed 8 centimeters from a thin converging lens of focal length 5 centimeters. Which statement about the image formed by the lens is correct? Okay. Now the focal length, principal focus, is at 5 centimeters from the optical center of the lens, and obviously 2f, 2 times the focal length, is going to be 10 centimeters from the optical center of the lens, and the object is at 8 centimeters. So this means that the object is placed between f and 2f. So the image now is going to be formed beyond, if we extend this, it's going to be formed beyond f and 2f. So the image that is formed beyond f and 2f is going to be enlarged, inverted, and real. Okay? So you can also have a look at this. I'll just form the lines and you can see. So here you can see that this is the object. It's between f and 2f and its image is being formed beyond f and 2f and the image is enlarged, you can see its size and you can see the size of the object and it is inverted, and obviously it is real because it's formed on the other side as that of the object. Okay, so the image is real and inverted. A option is going to be correct. You can always draw this and see what you end up with. Okay, and there is nothing wrong in drawing these lines and having a look at what the answer brings. Okay, so we are done with this. Let's move to the next question. Question number 21. Images formed by lenses and mirrors can either be described as real or as virtual. Which row describes real and virtual images to a point object? Okay. Real images formed when light rays meet. Okay. And the second option would be formed when light rays appear to diverge. So real images are always formed when light rays meet. They are not formed when the light rays appear to diverge, because that is how virtual images are formed. And if we look at the counter answers of these options, so A states that an image in a plane mirror is an example of a virtual image. This is correct. So when both of these are correct, A is going to be our correct option. Moving on to question number 22. The incomplete ray diagram shows two rays of light that have passed from one point on an object through a thin converging lens. Okay, which type of image is formed and on which side of the lens is it formed? If you look at the lens diagram, ray diagram, you are going to see that this is the case of a magnifying glass. And when you study the case of the magnifying glass, so you know that the image is formed on the same side as that of the object, and it is a virtual image, and you can see it from this side. Your eye has to be here. So as we know that this is an example of a magnifying glass, so the image is going to be virtual and on the left side. So C is going to be our correct option for that. Moving on to question number 23. The diagram shows an object O in front of a thin converging lens of focal length f. At which point will the lens form a sharp image of the object? Okay, let me draw the ray diagram for you. Okay, now I've made the ray diagram, as you can see. So the image of the object which was placed at O is formed at D. So always draw the ray diagram to see where the image is being formed. Okay, the first ray is going to go to the lens and then pass through the focal point, and the second ray is going to pass through the optical center of the lens that is going to be undeviated, and wherever they meet, they are going to form the image. Okay. Okay, moving on to question number 24. A converging lens is used to make an image on the screen. Which type of image is formed on the screen? Okay, whenever an image can be formed on screen, so we say that it is a real image. That is one of the points that distinguishes real image from the virtual one. The real image can be formed on the screen and the virtual image cannot be formed on the screen. And when a real image is formed, it is usually inverted. Virtual images are upright and the real images are inverted. So the image that is going to be formed over here is going to be real and inverted. You can also draw the lines to see that this image that is going to be formed over here, I'm drawing the lines roughly at the moment, so it's going to be inverted. Okay, and obviously if the image can be formed here, so it's a real image. So moving on to question number 25. The points labeled F are the principal foci of the lens. A beam of parallel light is incident on the lens. Which diagram shows the path of the light after it passes through the lens? Okay. Let's look at the diagrams. For A, the line that is parallel to the principal axis after passing through the lens has to pass through the principal focus, and it is not passing through it. It's converging somewhere before that, so this is not correct. If we look at our option B, the ray which is parallel to the principal axis after passing through the lens passes through the focal length. This is correct. The other ray as well passes through the principal focus, so this seems to be correct. Let's look at the other options. Now for C, it is not passing through the principal focus, it is passing like from a point way beyond that, and obviously this is also not correct. So B is the correct option over here as per ray diagram rules. Question number 26. An image is formed by a plane mirror. A second image is formed by a lens used as a magnifying glass. Which row states the nature of each of these images? Okay, we know that the image formed by the plane mirror is an example of a virtual image. And the image that is formed by a magnifying glass is also an example of a virtual image. We've discussed this case many times before. We've made that ray diagram as well. So now you must know that the image formed by the magnifying glass is actually a virtual image. So D is going to be our correct answer. That states both of them are virtual. Question number 27. The diagram shows a converging lens forming an image of an object. Okay, which statement about the image is correct? Okay, now if you see the ray diagram, this is again an example of magnifying glass. Okay, and you can see that the image is being formed on the same side as that of the object. It is an upright and a virtual image. And whenever this scenario comes into play, you have to place the eye over here to see the image. Okay, so the first statement says that it is real and can be seen at X, and B says that it is real and can be seen at Y. So the images formed by the magnifying glass are not real and they are virtual. So A and B can be cancelled. C states that it is virtual and can be seen by an eye at X. No, it cannot be seen by the eye at X. D, it is virtual and can be seen by the eye at Y. So this is going to be our correct option. I've told you this many times before as well in this topic. Okay, question number 28. Which diagram shows how a converging lens is used as a magnifying glass? So this is certainly not the case. The object is placed between F and 2F. Its image is going to be formed beyond F and 2F and on the other side of the object and lens. So this is not correct. If we look at our option B, so here the object is placed between F, a focal point, and optical center of the lens, and the image is formed on the same side of the lens, and it is a virtual image, and you can see it from here. So this is the case that satisfies all the conditions of a ray diagram for a magnifying glass. Okay. In C, the object seems to have been placed between F and the optical center of the lens, but the ray that come out of it are not correct, and they actually converge at a point on the other side of the lens. So this is not the correct ray diagram for a magnifying glass. This as well is not the correct diagram. You know that one of these has to pass through here, and the other that passes through the optical center of the lens goes like this, and they never meet or converge on the other side of the lens. Okay, so D is also not correct. Question number 29. A student draws a diagram representing three rays of light from a point P passing through a converging lens. Each point labeled F is a principal focus of which of the rays has the student drawn correctly? Okay. The ray X comes from here, passes through the principal focus. So yes, this is correct. The other ray that passes through the optical center of the lens goes undeviated and they will meet at some point later. So ray Z is also correct. As far as ray Y is concerned, it passes through the focal point on the other side of the lens. So if it comes to this point, after refraction from the lens, the ray has to go straight like this. Actually, ray X and ray Y are supposed to be reciprocals of each other. One was parallel to the principal axis before it passed through the lens, and it passed through the focal point after passing through the lens. And the ray that actually passes through the focal length, focal point of the lens before passing through the lens goes straight ahead. It gets parallel to the principal axis after passing through the lens. So this is not correct. The ray X and ray Y are the ray X and ray Z are the options that are correct. So B is the correct option. Moving on to question number 30. Which label distance is the focal length of the lens? Okay, the focal length of the lens is the distance between the focal point and the optical center of the lens. So A is not correct. B seems to give us the distance between the optical center and the focal point of the lens. So it seems correct, but let's look at the other options. Okay, C gives us the distance between the optical center of the lens and where the rays seem to converge, but this is not the correct ray diagram. The rays don't originate from the focal length from this side and then converge over there, because if they are passing through this point, then they will go straight ahead like this. So this is not correct, and the focal length is the horizontal distance between the optical center and the focal point of the lens, and it has nothing to do with the virtual distance. So D is also not correct. So B is our correct option over here. Question number 31. An object is placed in front of a converging lens. The lens has a focal length f. The lens produces a real enlarged image of the object. In which label position is the object placed? Okay, now we have two conditions, that the lens produces an image which is real and enlarged as well. Okay, we know that whenever there are a few cases of a ray diagram, so we know that when the object is placed between f and 2 times f, the image is formed beyond f and 2f, and it is real and enlarged. So we will just look at our option. This is f, this is 2f, and B is the only option that lies between f and 2f. So B is going to be that option. Let me make the ray diagram for you so that you can see that the image formed over here would be enlarged and inverted and real as well. Here's the ray diagram, and you can see that the image formed over here is clearly enlarged than that of the object. So B is going to be our correct option for this. You can always draw ray diagrams to see which option gives you an enlarged image or whatever is required in the question statement. Okay, so let's move forward. Question number 32. Which statement about a converging lens is not correct? Okay. A ray parallel to the principal axis of the lens is refracted through the principal focus. So this seems to be correct. Obviously, we've seen it many times in the ray diagram. Okay, B states that all rays of light refracted by the lens pass through the principal focus. No, this is not correct. All the rays of light that are refracted by the lens don't pass through the principal focus. We've seen the one ray that passes through the optical center of the lens and it goes on undeviated. We have seen that when ever a ray before refraction passes through the focal point of the lens, it goes straight ahead and then does not go through the principal focus. So this seems to be the option which is not correct. Let's look at the other options as well. The distance between the center of the lens and the principal focus is the focal length, so this is correct as well. The principal focus of the lens is a point on the principal axis. This is correct as well. So B is the correct option, which is actually not correct. Okay. Question number 33. The diagram represents a converging lens forming an image of an object. Which distance is the focal length of the lens? So focal length is the distance between the optical center of the lens and the focal point of the lens. So this is going to be that distance, which is QR. Okay? Because this is the optical center of the lens and this is the focal point of the lens. As we can see that the rays after refraction from the lens are passing through this point. Okay? So QR is going to be our correct option over here. Moving on to question number 34. Which diagram shows an image of an object is formed on a screen by a converging lens? So if an image of an object is formed on the screen, it is going to be a real image. Okay, so we are going to look at our ray diagrams and see what we can find. Okay. We know that for a magnifying glass, the image is not real and it is virtual, and for that case the object is placed between the optical center of the lens and the focal length of the lens. So let's look at the options. This is 2 times focal length. So if we draw it over here like roughly, so we see that this object is placed between like at 2f roughly, but the ray diagram, when the ray is parallel to the principal axis, has to pass through the focal point of the lens. Okay, and it is passing through 2 times focal point of the lens. Okay, so this ray diagram is actually not correct. If we look at the option B, again the ray which is parallel to the principal axis after being refracted from the lens is passing through 2 times the focal point of the lens and not the focal point of the lens. So this ray diagram is also not correct. So if we look at the option C, there is this object and it is passing through the focal point of the lens and it is going to form a real image over here. So C seems to be correct, but let's look at the option D as well. Okay, this again is not a correct depiction of ray diagram. So the ray that is parallel to the principal axis after refraction from the lens is passing through the point F, but the other one has already passed through the focal point of the lens before it refracted from the converging lens. So this ray is going to go on straight ahead. Okay, so this ray diagram is also not correct. So C is our correct option. Okay. Moving on to question number 35. When converging lens forms an image, okay, what is the nature of this image and can it be formed on the screen? So if we look at the ray diagram, we can see that the image formed is inverted and is on the other side of that of the object. So yes, this is a real image, and obviously, if it is a real image, it can be formed on the screen as well, because this is the distinguishment that we get between the real image and the virtual image, that real images can be formed on screen and the virtual images cannot be formed on screen, and virtual images are on the same side as that of the object, and the real images are on the other side. So the nature of the image is real, and yes, it can be formed on screen. D is our correct option. Looking at question number 36, the converging lens in a camera is used to make an image on the film. Which label point could a large object be placed so that it makes a smaller image? Okay, this is the case of a ray diagram in a camera. Okay, in a camera, the object is placed way beyond 2f so that its image formed on the screen or on the film is smaller than that of an object. Okay? So we see that this is 2 times focal length, so the object is placed beyond 2f so that its image can be formed between f and 2f, and it is diminished, real, and inverted. Okay? So A is the only point over here that seems to satisfy this scenario. So A is going to be an option. I'll just draw a ray diagram for you so that you can see that if we place a big object at A, it is going to form a smaller image of that, a diminished image of that on the screen. Okay? So here you can see that if the object was placed at A, it creates a very small and real and inverted image over here on the screen. So you can see that A is going to be our correct option for that. Okay. Moving on to question number 37. A converging lens in a projector is used to make an enlarged image of a small piece of film on the screen. At which labeled point could the piece of the film be placed so that the lens produces this image? Okay. Whenever we take an example of the projector, so this is a case in which we we place the object between f and 2f so that its image is formed beyond f and 2f, and the image formed is enlarged, inverted, and obviously it's going to be formed on the screen, so it's real. So let's look at our options and the points which seem to lie between f and 2f. So this is f and this is 2 times f. So C is the only point that lies between f and 2f. So the object is going to be placed here, and its image, which is large, inverted, and real, will be formed over here. So let me make you a ray diagram for that. Here you can see that when we placed the object at point C, which was a point between f and 2f, so its image is formed beyond f, and obviously 2f is going to be, this was our f, and 2f is going to be here. So it's formed beyond f and 2f, and you can see that it's a way enlarged image than that of the object. So C is correct over here. Let's move on to question number 38. A student draws 3-ray diagram of light from point P through a converging lens. Each point labeled F is a principal focus of the lens. Which of the ray are drawn correctly? We've done this question, I think, 2 times before as well. So just leave it over here. Acha, a thin converging lens is used to produce a screen, produced on screen to focus a focused image of the candle. Various focus images are produced. We've done this question before as well, so we are not going to do it. Question number 40. Which diagram correctly shows rays of light passing through a converging lens in a camera? Okay, whenever the camera is being used, so the image formed is going to be inverted. Obviously, it's formed on the film, so it's going to be real, and it's diminished. It's smaller than the object. So we are going to look for these 3 things in order to see that which ray diagram correctly shows the right light passing through a converging lens in the camera. So over here, if we see that the object is smaller and the image is larger, so the image has to be diminished smaller. So A is not the correct option. In the option B, we can see that the object and the image are of the same size and the image is not inverted, it is upright just like the object. So obviously this is also not going to be the correct ray diagram. In the option C, we see that the object is upright, the image is inverted, and the image is way smaller than the object. So C seems to be the correct option, but let's look at the D. Okay, over here in the D, the object is upright. The image is diminished, but the image is upright as well, and it is not inverted. So D is also not the correct option. So C is our correct option. Let's go to question number 41. An object O is placed in front of a converging lens of focal length f. At which point will the top of the image be seen? Okay, let's make the ray diagram for that. As we have to draw the image of the top, so we are going to take two rays that start from the top of the object. So one ray after refraction through the lens passes through focal point and goes here, and the other one passes through the optical center of the lens, and they both seem to converge at point C. So C is going to be the correct point where the top of the image of that object can be seen. So C is the correct option. Let's move to question number 42. The diagram shows the path of a ray of light passing through the principal focus of the lens. Which broken line shows the direction of the ray after it leaves the lens? Okay. So the ray of light has passed through the focal point of the lens before it passed through the lens and refracted. So this ray that passes through the focal point of the lens before passing through the lens goes straight ahead like this. I've told this many times before as well. So B is going to be our correct option. So this brings us to the end of our topic, thin converging lenses. So I hope you found this helpful. Inshallah, we'll see you in another video. Up till then, take care of yourselves, and if you found anything helpful in the video, kindly remember me in your prayers. Thank you, and Allah Hafiz.